Howdy, I'm Edward Coderman, and I'm here to talk to you about best practices. Well, more specifically about when not to use them. Today we're going to talk about some examples from my career, and then we're going to go over the big picture, and along the way we're going to do some takeaways, hopefully that you can use in your day to day. So let's start at the beginning of my career. When I started as an enterprise programmer, I'd already been coding for a long time. But that was my first time at a real shop with other developers on a team, and it was a C-sharp shop, they declared. And I'm a big rule follower, and it's what makes me a good developer. And so started learning C-sharp. I didn't know C-sharp, but I started learning C-sharp. And along the way, I'm learning all kinds of stuff because it's a big shop, and I'm learning things that I didn't do in my personal career. So I was learning about dependency injection and test-driven development and all the things you do in a real enterprise sort of situation. And so I'm drinking from the fire hose, so to speak. And about a month in, one of the higher-ups at the company stops by my desk. Now this guy, he was high in the company. He was like best friends with the president. He says to me, I need you to create a bunch of shared folders on a shared drive. And I was like, that's kind of a weird request, but okay. He says, I'm going to send you an Excel file with a bunch of folders, and I need you to put them on a shared drive. And I said, well, how many folders do you need me to create on a shared drive? About 500. Okay, this is not the kind of thing you can just do by hand in a few minutes. So I started thinking about what it would take to do, and I'm new to C#. I was like, okay, well, there's file management, and I don't really know about how to handle the operating system files in C#. And, well, this is a shared drive, so it's probably a little more complicated than just managing the files directly on my computer. So I have to learn that piece. And then I was like, okay, well, there's reading from Excel, and there's the whole Office.NET suite complications that are involved there. So that's going to take me a little while to figure out. And then I was like, and then should I read it from the email directly? I don't really know how to do that, but I probably should figure out how to do that in case he sends me another email so I can just automatically process it. And I was like, that's a lot of stuff, but I was optimistic, probably too much so in my early career. So I said, I don't know, 3 or 4 hours, I can probably figure that out. He kind of frowned at me and walked away. And I thought that was a little excessive. I thought I was being generous. So sure enough, a few minutes later, I still got the email in my inbox, though, with the Excel file. And it looked a little something like this. Now, obviously, it was a lot bigger, a lot more companies, but it was a bunch of company names, and he needed them created as folders on a shared drive, just like he said. Pretty simple. So I was about half an hour pecking away at Visual Studio when my manager came up, the software development manager at the company, came up to me and asked me about the project. And I explained to him what had happened and sort of the problems I was having along the way and the challenges I faced with the learning curve involved and the reason it was going to take me 3 or 4 hours. And he gave me kind of the same frowny look, and he said, come over to me, and brought me over to his desk. And he cracked open the file just as I had. And he said, all you have to do is this. And he clicked on it, inserted a column here. Let's insert a second column right before that. And he said, doop, and then he went. And with Excel, there's this wonderful feature. You can just double click here and double click here. And then we can save as. And we just go down here and select CSV. And I think he had it tab delimited, but I'm going to use a pipe here. Not a big deal. And now we can open it up in our text editor, which is what he did. Ooh, I screwed up. Did I miss it? Hey, we scrolled down. That's fine. Let's save it. And there we go. So now we can easily replace. And you know what? That's not quite right. So we'll just do this. And we're done We copy this, and that's what he did. He copied that, and he pasted it into a terminal. And half a second later, he had 500 folders created on the shared drive. It was about 2 minutes with explanation to me of how to do it. So I took that, and I went back to my computer, and I played with the little script and tried it myself, and managed to do it a couple times, delete the follow folders, recreate them 2 or 3 times before I sent an email off to the higher up and let them know that it was done. So was I wrong there? I mean, I was trying to do what they told me to do. I was trying to use C# for everything. Was my manager wrong there? I mean, he wasn't using C# like he said he was, but he also got it done so much faster. Was the higher up wrong to give such a weirdly non-development task to a developer? I don't think anybody was wrong. That's kind of the point, right? It's not about the code. It's not about C#. That was the general rule there, but it's not about the rule. We're tasked with just getting the job done. We're there to solve the problem. That's why they give us admin access. And that's a shout out to those of you who don't have admin access. I'm very sorry for you. But there's a reason that your job is problem solving. It's not about lines of code. And that's a shout out to those of you who are being judged on how many lines of code you write. I'm very sorry. Write more comments. It's not even about software development. It's about problem solving. Our task as developers is to solve the problem. Our managers, like in my example, often were developers and know what they're doing, but they don't have to be. Their job is to tell us, this is the problem I need you to solve, go solve it. Especially when our role is architect. At least with a developer, you have the excuse, when I was new, I'm trying to do things the way I'm told. But the architect's job is to tell them, you're the planner. Our job is to plan for every eventuality, or if we failed. Wait, that's not right. Our job is to plan for every eventuality the client comes up with, or we failed. Which is somehow harder. Okay, so we can't plan for every eventuality the client comes up with. But that's kind of why companies have converted from waterfall to agile, right? Because now when the company changes their mind in 2 weeks, we've caught that and captured that change and managed to make it earlier rather than later. And that's our job, to plan for that and handle that. So if the client suddenly says, well, Agile's not early enough for me, I need to meet with you every week. Is that wrong? Well, to some extent, your goal with Agile is to ensure that we get some balance there, right? Waterfall was complete focus for developers. And if we went the other way, there'd be constant meetings and the developers would never have any time to focus. But if your UX team just made some major changes to the way things are going to work in the application, maybe you should just set up a meeting with the client. There's no reason to wait till the sprint end meeting to explain to them that, oh, yeah, by the way, nothing works the way it used to. Nothing here is set in stone. We're the writers of that stone. We're the architects. Everything's optional. Nothing is dangerous, despite what you may have heard about singletons. At Apple, they had a slogan. If you went and applied for a job there back in the 90s, I guess, their slogan was, think different. Does that sound like we need you to follow every best practice every time? No, it sounds like be creative, come up with a different solution. Which brings me to the next point about best practices, is sometimes they're not really best. And by that I mean, you need to stop and think about it. Our job as architects is to decide what is worth doing. It's about trade-offs, right? You sometimes are trading off speed in network for less hard drive space, or you're trading off more memory for less servers. There's various and sundry different trade-offs. That's what we're doing. The best practice idea is, here's an optimization in this specific scenario of a trade-off, a perfect optimal trade-off in this specific scenario. But we're not always using those correctly. We're applying them in the wrong cases. And sometimes we're just completely implementing them incorrectly. So be wary that it's actually the best practice in that scenario. A great example that's very much in the news right now is AWS. Amazon have found out that the founders of Lambda found out that serverless is crap for them. They're too big. The idea of having a bunch of little serverless microservices all over the place is not the optimal way. It costs them millions of dollars more a month to run that than it does to just have a giant monolith. And so that's what they did. Was that wrong of them? I think they know what they're doing, don't you? But that's what I'm talking about here. So let's look at another example. So now we're going to look at some Python, and then we'll do some JavaScript, and we'll talk about Java and somewhere in there, and then we'll get to some C# examples. This is a pretty basic Python example of connecting to a database. We're doing things fairly Pythonic. We're using some try catch here so that we nicely close our database connection. We have our environment variables getting set, and now I wouldn't worry about these being nullable, so we didn't, because you don't want to try and connect to the database if these aren't there, so we're going to leave these. It's okay that they show up null. We want an error to happen if our database connection is not configured correctly, right? So we're a Python guy, we're architecting this Python app, and we're like, you know what? Our developers need to be able to run it on their machine intelligently. So we should move these environment variables into a .env file. That way we can set them up and they can point it to localhost, and then on the server we can swap it out for production code that points to the actual database in RDS or whatever it is. Okay, that sounds nice and clean, so we'll do that. And so you set that up, and then you go, all right, now it's time to hook that into the main application file, and we import the database, and oh yeah, we need to import this load.env stuff now for loading the environment variables. And let's go ahead and create another nice clean class. We'll set up our database connection, and we'll set up a main function that loads the environment, and there we do stuff. And then we'll run that only when the app runs. So we go to run this file, and I don't think I have the, I don't think I have it here, but this will throw an exception. And the reason this throws an exception is because of how imports work, right? We import the database py file, and that's going to automatically run all of the code in here, and there's not really any code getting run in here, so that's okay, right? Well, we were Pythonic, and so we use data classes, and data classes creates this instance it can copy of this database connection class, and in order to do that, it has to load this environment variable, and that's where we throw our exception. So the entire app doesn't work? What do we do? Well, we could just do this. We don't really need the class anyway. It was fancy syntactic sugar. We could just run our main function like that, and we can load our .env and then import the database and then create the database connection, and that'll work. But I imported the database down here. It's fine, guys. This is probably a 30-line file doing a bunch of imports, and that's it, because the work actually happens somewhere else in the code. The point is that your developers are going to have less cyclomatic complexity looking at this. And it works. So did we break best practices, or did we just do things differently because it was optimal for our scenario where we needed a .env file and a database connection class? Let's move and look at dependency injection, one of my favorite tools in the world for testing. Now, dependency injection allows us to test cleanly without connecting up 50 different dependencies, so we can write a test that runs in 1/10 of a second instead of a test that runs in 10 minutes. which is important because if your tests take too long to run, then your developers aren't going to run them. So, what's the point of dependency injection outside of testing? Well, it's supposed to allow you to swap in dependencies at runtime. And I can't think of a whole lot of scenarios where I actually need to swap in dependencies at runtime. But there are some out there, and if you're running into that scenario, then maybe you can benefit from inversion of control. But most of the time, it's overkill or automatically implemented on your project by some tool called AutoWire, which doesn't allow for you to swap it out in the constructor, thus defeating the purpose of the dependency injection in terms of testing. So be wary. Anyway, this is an example of some JavaScript code. We have an HTTP client, does something really simple, just runs fetch, converts it to JSON, and returns the actual data from the HTTP service. This is existing code in your code base in this example. And we're going to look at some more existing code in your code base in this user service. And it has a get users call, and it pulls that HTTP client and calls get. Pretty simple. And because this is existing code in your user base, it's exported, and that means that other files throughout your code base depend on it. But we need to test this. And so we want dependency injection to swap out this HTTP client. And so we create this dependency injection version of the user service. And it exports a class instead. And that allows us to pass in the HTTP client. We can probably get rid of that, and then we're good to go. We're able to then call just get as long as the HTTP client implements get. But if this is in use in 30 different places in your code base, when you implement this, you have to change that line of code in 30 different places in your code base. And so your merge request just got a whole lot bigger. Why didn't you just do this? Look how different that is. We added an HTTP client parameter to the function that already exists. And we put an automatic value to it of the old HTTP client, so all the existing lines of code will run as is and fill in as is. But now when we run a test, we can specify the HTTP client as a mock, and it'll work. This is technically dependency injection, right? I'm injecting the dependency here in the parameter. But everybody assumes this is what dependency injection looks like because they're used to it. It's best practice. JavaScript's a functional language. I don't even think ECMA meant to implement classes except they had to because developers didn't know what they were doing with functional languages. I'm kidding. But only a little. AutoWire is another example I talked about, right? AutoWire drives me insane because it does stuff like this for your dependencies and gives you no constructor that you can swap out dependencies, so you can't write clean tests. I'm going to do one more example here. Back when I was working at NASA, I drew the short straw. I got to stay late to do a release of a brand new application to the internal infrastructure. That's not a new version, that's a brand new application from scratch. And so at NASA we had a tool for releases, so I had to build the application in the tool, and the tool gave the DevOps person like a wizard to step through so they could actually plug in all the values that were needed. And so I, using best practices at NASA, compiled it for the tool. And this was C#, so we had an XML configuration file. And in that XML configuration file, we had all the values that were being built by this tool. So the tool would fill in the values in the configuration and then deploy it. The DevOps person could deploy it easier. So I packaged this up, sent it off to the DevOps guy after hours at work. I'm frantically clicking the refresh button, and the application page turns into a 500 error. I get a phone call from the DevOps guy, and he has no idea what's going on, and neither do I. So he enables long error messages, and we look at the error message, and it's the configuration file that he built. That doesn't make any sense. So then he showed me his password. That was best practices with all the fancy characters, the special characters you're supposed to use in a best practices password. Now, don't get me wrong. The tooling we were using for builds, it tried to manage this. It tried to handle special characters, but for some reason this one just managed to get through. I don't remember what had happened exactly. Maybe it was like a backslash and a caret, but it was really awkward. And so somehow the database password got stuck in like this, and it was completely unable to function. The application would not run. Now, I can see you architect brains thinking, you're like, gosh, now we need to go and re-implement an entire deployment tool. It's going to take a month. We're going to have to sidetrack all of our projects. This tool is crucial. It's used for every deployment. No. You know what we did? We changed the password. He wrote a different password. And we went home. The application worked. For all the effort we're doing as architects, sometimes that's the solution. Meta used to be called Facebook, right? And their slogan was move fast and break stuff. That sound like somebody who's stopping to think about best practices? No. But the key to those slogans that I'm mentioning is they also changed them when they were no longer relevant. Which is the whole point. Patterns are guidelines. Artists don't use a ruler for everything they do. They use a ruler for when it's relevant, and then they use a different tool or their own capability and creativity. We make the rules. That's what architect is all about. We've moved to a whole different role here. We're not writing code. We're not following the rules anymore. We are the rules. Sometimes you just need an Excel export. Sometimes you just need a different password. Sometimes it's time to throw out a bad idea, like AutoWire. One of the most common statements in programming, I think the first thing I learned, the first acronym I learned in programming was don't repeat yourself. And in the case of don't repeat yourself, we're talking about one of the most important best practices in programming. Every time we repeat code, we have to maintain that code in two different places. That's horrible. You do not want to have to maintain code in multiple different places. So don't repeat yourself is a very important best practice. But there's a very, very blatant exception to don't repeat yourself. And that's tests. Whenever you're writing tests, you should repeat yourself over and over and over again in every single test. Because you don't abstract away code in tests. Then you can't read it. Then you have more things to test. You might as well write tests for your test at that point. And then future developers who come on the project can't look at the test and figure out how things work. So for every rule, there's an exception. So you need to make the decision when it's time to make that exception. And when it's not, that's important too. So the next time some developer comes up to you and says, well, you got to do it this way because it's a best practice. I want you to sit there and look at the forest for the trees and ask yourself, is this really a best practice here in this scenario? Thank you for your time.